Alright, now we're going to be doing the third last from the back. This is calculate the length of a vector given as a 1D array of integers. So a vector is just a kind of a line, you could say, that points in the 3D direction of where something is, kind of, or where something is going. So of course we're going to start this with start, and by inputting our array, we are then going to set an almost classic loop, rather it is the most classic loop, as I is smaller than n. Now, here we're going to have to do a bit of explaining, as how do we find the length of a vector? Well, it's kind of simple. It's okay, I guess it's kind of simple. So, this arrow above A is our, sorry, my bad, it is our vector, and of course what you're also going to have to forget here is k. We add this k because we want to have we want to have an amount of well, you know, our result essentially. Now this is a vector, and of course these lines next to it are absolute value. So an absolute value just means it's always going to be positive. Now this is equal to sigma of a I squared of a squared ai squared. So this is essentially like writing down ai squared, but it's the proper mathematical notation, not the flowchart one. And this means that this is the addition of all ai, so all of the numbers. Of course, going to have I0, as this is our amount of times that we're doing it. This is our amount of times that we're actually going to be calculating this. n-1 times. This is a bit of a different. There's a bit of a different way of counting how you do things here. So that's why you have I is smaller than n. And of course, we do the square root of this, because what we're going to find is that when we do a vector, we're going to be counting also Pythagoras theorem, kind of. If like the way we do a vector, you don't. I mean, if you're not going for computer science, you don't need to know why this is such. Now, if it is true, what we're going to do is we're going to have k is equal to k plus ai squared. So what I said with the Pythagorean, it's kind of different because you're taking essentially all the lengths together, all of them squared, and we have a root of this. So this is kind of like you could call it an average, but it's not really. So it just finds the length of a vector. It's just something that it's not easy to understand, at least for me, not easy to not understand, but explain for me, at least. Then we increment I plus plus. This seems very easy, of course. It's just that this seems different. And now sigma, it always just means the sum of all numbers in this. And so like the conditions and, you know, just a different way to writing it down. Now, if it is false, what we're going to be doing here is we're going to have another variable, because I guess you can do that. And why I said you can do that, because after we're done calculating, we need to have the square root of k. So k is our sigma of ai squared. I guess you can also just output the root of k, but I guess this is better because you might need L. If you're like doing more advanced programming, you can save L for a different time.